Hello and welcome today. Today we're going to talk about what a truth table is and how to write truth tables. So basically, a truth table is a form of logical inferences. But first of all, let's get back to why truth tables are useful here in a complex logical expression. As you can see on the screen here, this is our logical expression, and then we have three simple sentences here. So basically, that means 2 to the power 3 or 8 different combinations. We have a negation and two conjunctions. Just by looking at it, you can tell me the overall logical expression is true, right? When the component parts are true. Other words, you can tell me if the statement is true if P is true, Q is true, R is also true. But if what about if P is true, Q is true, R is false? What about that? There's a lot of different combinations here. Even though we have three simple sentences. Looking at a more complicated expression, this could be a little bit harder to solve, but at the same time, this would not be that hard to solve. Because using a logical connective, on the other side, well, this is going to be a little bit more complicated for you to figure out. Especially, if I replace one of these variables and add another variable, and I give you 4 different variables to work with. For example, if you look at it right here, pretty soon this gets out of hand due to the point where looking at just trying to reason your way through your head becoming difficult. What a truth table is and how it allows us to figure out. These basic expressions are logical expressions that are true and false based on what component parts are true. Truth tables are an algorithmic way of something that's simple and then can work through logically step by step the right answer. So what we're going to do here is a look at how to construct a truth table. Now I'll give you a very simple example, and then later on in the future lectures we'll look at more complicated examples. Writing a truth table is a four-step process. So the first thing is that you're going to take a logical expression of big expression is to break it down into simple sentences, and then break it down into its component parts and write each sentence simple. You may write each column for each sentence. After you've done that, you're going to create additional columns for each additional more complex expression. From small to big, you take smaller logical expressions and write down a column for those, then you create bigger ones based off the logical expressions you created previously. After you fill in all possible truth values for the simple sentences, as you can see, we filled in the P, true, true, false, false, and for Q we filled true, false, false, true. Now we're going to go from left to right in order of complexity, and each of these columns and using previous truth values to deduce the values and current column they're looking at going through. Eventually you'll hit it and we'll be done looking at whether it's P or Q gets right as I've got a disjunction here, or whether I've got two simple sentences to write columns as the next table. In the end, it's more or less complicated as P or Q is disjoint between P and Q, and then step 3 for us is to fill in all possible values and to go through everything possibly. So we already have filled in all the values to save time. And then remember back to our lecture or previous learning disjunctions in that expressions know that P or Q is when at least one of those two simple sentences are true. As you can see now, filling this up is a true. So if either one are true, so this will also be true. And then if both are false, obviously that will also be true. If one of them is, and then if both of them are false, sorry, I meant to say that this will also be false. And this one will be true then. That's it. Thank you. See you in the next lecture.